Alright, throughout the course of this video, we're going to be mostly trying to answer one question, which is how will Hurricane Hilary impact California? Now, I haven't looked into it too much just yet, but there is a few things that I already know. One, it's a Category 2 hurricane as of right now, and I'm pretty confident that it's not going to still be a hurricane by the time it gets to California, although it will lead to some impacts like some potential flash flooding down in Southern California, some gusty winds, and then definitely some thunderstorms throughout the state, although we'll have to see exactly what happens there, and hopefully that's one of the questions that we get to answer throughout the course of this video. So right down there you can see Hurricane Hilary, and the first thing I notice is how much stronger it looks in the last 12 to 24 hours. You can see how organized it's getting, and you can actually start to see the eye of the hurricane starting to show up there. Whenever that happens, you know the storm is becoming a lot stronger. We can also look at it on mid-level water vapor imagery. Just another way of seeing it, because when it comes to water vapor, that's one of the major impacts that'll have on California, is it's going to be pushing a lot of moisture into the states. We're going to see very large amounts of rainfall, and we'll look at the exact inches expected in just a moment. I think maybe the most useful thing to do at this point would be to just look at where the Hurricane Hilary is right now. You can see it's off of the western coast of Mexico, and then it is set to move up Baja California. Now, maximum sustained winds, you can see right there around 110 miles per hour, minimum central pressure 960, and we are expecting this to continue to increase in intensity. It's still over very warm water, and as long as it's over warm water, it's going to get stronger, and then as it goes over cooler water, it's going to get weaker. So yeah, this could actually be a good place to start, which is just reading the key messages for Hurricane Hilary. Before we get there, maybe we'll just get a brief outline of the timing expected on this. So there's the hurricane right now. It's going to continue to strengthen through Saturday, and then by Sunday morning, it looks like it's getting pretty close to the U.S.-Mexican border, and then by Sunday evening, it looks like it has moved into California. At that point, it's most likely going to be a tropical storm. So let's see if we can see the expected winds, where you see probability of tropical storm force winds. So 1 minute average of greater than or equal to 39 miles per hour from all tropical cyclones. That's what it takes to be a tropical storm. And it looks like by the time it gets into California, you're seeing a little of that yellow there, and then mostly into the green. So that's about a 5, or you could say a 10 to 40% chance that we still have some tropical storm force winds by the time it gets into California. Now let's check out the warnings cone static images. So this is where, let's see if they have M. So M is going to be major hurricane, which means greater than 110 miles per hour. H is going to be 74 to 110 miles per hour. So hurricane, which would be category 1 or 2. Major hurricane would be greater than a category 3. And then tropical storm, 39 to 73 miles per hour. Tropical depression, less than 39 miles per hour. So it looks like between 12 p.m. Sunday, that's where it's still a hurricane over Baja California, and then 12 p.m. Monday, it's a tropical depression over California. So the reason it decreases in intensity so much is for two reasons. Once it's over this water closer towards California, it's going to be less than 80 degrees, the surface water, and if your water is less than 80 degrees, then the storm's going to start weakening. And then once it gets over land, it's cut off from that energy source entirely, and then it's going to weaken much more rapidly. And it also may be weakening as it goes over Baja California, if it can trend a little bit farther to the east, because we do have some mountains around Baja California that we can maybe look at on Google Earth in a minute just to look at the topography down there. But if it goes a little bit farther east, and hits into those mountains, that's going to really disrupt how organized this storm is looking right now. And then that could completely change the forecast. So big thing that I want to emphasize throughout the entire course of this video is that this is still a few days out. You can see the timing on that over Southern California, 12 p.m. Monday. And I can guarantee that we're going to see some changes by the time that happens. So this is a very preliminary report. We're trying to get a basic idea of what's going on, but we're definitely going to see some changes as we move forward. So just taking a quick look at U.S. rainfall, this is what's expected as of right now. You see most of it is in southern and kind of southeastern parts of California. And where you see the orange, that would be 6 to 10 inches, which, if you know this part of California, you don't often see very much rainfall there. So that could be multiple years worth of rainfall over the course of maybe 6 to 12 hours. So that is where the flash flood potential really starts to come in. Not seeing as much for the Central Coast, the Bay Area up in Northern California. So that's where I'm actually a little bit worried about the chances for some passing thunderstorms leading to dry lightning and then some wildfires. So we could have flooding in Southern California, but wildfires breaking out in Northern California. That's one of the things I'm still very questionable about, though, is the impact this could have on wildfire. It might bring a bunch of moisture into the state, might bring some great rainfall, and significantly reduce fire danger, maybe for the rest of the season, which would be amazing. Or we don't get as much rainfall in Northern California because it tracks a little bit farther east, and then we maybe get some thunderstorms that lead to lightning and some fires starting. So there's quite a spectrum of what this storm could end up doing. Now this is greatest flash flood risk over the next 5 days. Looks like Southern California has a moderate, so at least a 40% chance of flash flood risk, going into a slight chance where you see the yellow, and then less than 5% chance is your green. So that's stretching up into the Central Coast, into the Tahoe area, and then up into Northern California as well. So that is a lot of the, we already looked at that one. Looking at right there, surface wind. Let's go to the key messages, because this is probably the most important thing that we're going to go over throughout the whole course of this video, because you can bet that the meteorologists at the National Hurricane Center have spent hours looking at this thing, and then these are the 4 most important points that they have put forward. So let's just take a little time, see if we could read this, and maybe we'll find some maps that go along with what they're saying as we're reading it. So heavy rainfall associated with Hilary may produce areas of flash flooding and result in landslides over portions of Baja California Peninsula from late Friday into late Sunday. Rainfall impacts from Hilary within the southwestern United States are expected to peak this weekend into Monday. Flash, urban, and arroyo flooding is possible with the potential for significant impacts. So right there it's saying heavy rainfall from Hilary is going to move into the United States with the potential for some significant impacts. The threat of hurricane-force wind impacts is increasing along the west central coast of the Baja California Peninsula, and hurricane watches could be issued for a portion of that area tonight. Notice that's for Baja California, not California, where they're talking about hurricane-force wind impacts. Tropical storm conditions are expected to spread across the southern portion of the Baja California Peninsula by late Friday, where a tropical storm warning is in effect. So it doesn't really mention if it's going to be a tropical storm as it gets into California just yet. Maybe it'll get to that later. The threat of significant wind impacts continues to increase for the northern portions of the Baja California Peninsula and the southwestern United States, especially in areas of mountainous terrain. So, more wind impacts north of Baja California into the southwestern United States and especially in the mountainous areas. Although it is too soon to determine the location and magnitude of these impacts, interests in these areas should monitor the progress of Hilary and updates to the forecast. Watches could be issued for portions of this area on Friday. So right there, it's basically saying When it comes to the wind impacts, and honestly I'd say even with the rain impacts as well, it's still pretty far out at this point. So since we're going to see some changes, don't really want to lock in any numbers just yet, although we will look at some of the potential numbers that are the best we know of right now in just a moment. Finally, large swells from Hilary will spread northward along the coast of southwestern Mexico and the Baja California Peninsula. These swells will reach the Gulf of California and northern portions of the Baja California Peninsula later this weekend. And I did look at the surf line forecast, wasn't seeing any large surf for the central coast just yet, but I imagine we will have some large waves going into Southern California. So now let's check out the National Weather Service, because I did see they're already issuing some flash flood warnings down in Southern California. You can actually just see there's a lot going on for California right now. We have the red flag warning up in Northern California because of thunderstorm potential, bringing some lightning, some gusty winds, and we already have a lot of fires going on up there. I did a whole video about that. You can find that on my channel. In the Central Valley, we have a heat advisory. And then in Southern California into the southeastern portions of California, that's where we have the flash flood watch. So we're focusing on Hurricane Hilary throughout the course of this video. So let's just click into, let's go Southern California and see what kind of banners they have here. So they've got excessive heat midweek with a major heat risk, and then excessive heat warning in effect today. Looks like there is going to be a little bit of a cooling trend as we move forward, which is good news there. And then shower and storm chances continue. Let's see if they say what day it's going to start. Shower and thunderstorm chances greatest 20 to 40% across south central Arizona today. Rain chances ramp up across the entire region late this week through the weekend. Flooding concerns increase this weekend with a slight risk for excessive rainfall across portions of the region and a moderate risk for southeast California Sunday into early Monday. So let's check out the flood watch and see what it's saying here. So the timing on that is going to be flood watch in effect from Saturday morning through Monday afternoon. And that's due to excessive rainfall. Where, the long list, certainly not going to read all of those. When, Saturday morning through Monday afternoon. Impacts, that's an important part. Excessive runoff may result in flooding of rivers, creeks, streams, and other low-lying and flood-prone locations. Flooding may occur in poor drainage in urban areas. Area creeks and streams are running high and could flood with more heavy rain. Additional details. A rich moisture plume will accompany Tropical Cyclone Hilary as it progresses north along the west coast of Mexico and into Southern California this weekend. This will lead to widespread heavy rainfall across Southern California, southwestern Arizona through this weekend. Combination of rapid onset and slow response flooding is expected with high rain rates and rainfall totals. Rainfall totals will be highest in the mountains of Southern California in upslope favored regions and with banding, with rainfall amounts forecast around 2 to 4 inches across Southern California and southwest Arizona, and localized amounts up to 6+ inches. There is potential for considerable flooding across the region. So we've looked at a number of sources talking about the rain that's expected. So now let's actually try to see if we can figure out how much rain is actually going to be coming into California, which is why we have these widespread flood watches in place. Now again, this isn't just for California. The impacts from Hurricane Hilary do go into Arizona, Nevada, even Utah as well, but being a Californian meteorologist, I'm going to be focusing on that throughout the course of this video. So models, I have been hearing that the GFS has been doing better with this system than the other models, although we could take a look at a number of them to see maybe how they compare. But let's just check out the GFS first, because that's the one I've heard is performing the best so far. And let's just look at precip type and rate. And I'm going to change this to Southern California first, just so we're in the local time right here. So 5 p.m. Pacific. And let's make sure this is going to be a run that shows when that rain's going to be coming in. So Saturday, we're starting Saturday at 8 a.m. already starting to see some of the rainfall showing up in Southern California. Then a bit more of the heavy rain where it transitions from the green color to the yellow and orangish color. That's at about Saturday 2 p.m. Bit more of that as we get into Saturday 5 p.m. And keep in mind, this is before the low pressure itself has even moved in yet. And I think the best way to see that is by going over to windy. And let's check out wind gusts, because that's going to show your storm down here. We can actually just click through. This maybe should have been the first thing I did, because this is a pretty great animation of what's going to happen. Now keep an eye on the numbers that you see inside of that low. Notice how it's been dropping. That means the storm's getting stronger and more intense. And as long as you see those numbers drop, that means your storm's going to be getting stronger. See how it's going down to 973? And then once those numbers start going up, that means your storm's going to start weakening because it's getting to the cooler water or it's moving in over land. So that is Saturday at 8 p.m. You can see where that storm is. Matching it up with this model, let's go to Saturday at 8 p.m. This is where there's some rain definitely showing up in California. And we did have some heavier rain earlier in the day when you're maybe seeing some more thunderstorm activity. Now let's go to Saturday at 11 p.m. Let's just fast forward. Now you notice that number is up to 994. That means the storm has been weakening. But you can see it starting to move closer towards California. It looks like the center is over like that California-Mexico border Sunday at 8 p.m. And this is the ECMWF. So we should probably put on the GFS. Interesting, so that is where some of the difference between those two models comes from. You can see GFS has it maybe going a little bit farther to the west. I could zoom in here so we could see it better. Has it moving farther to the west, which is going to keep it over the water longer, so then it keeps a bit more of its energy. Whereas ECMWF, that's going to move it to the east a little bit. So you look at the number there, 995 millibars versus the GFS, that's going to be 979 millibars. So you can see the little differences between the different models. So not only is an individual model going to change by the time the storm comes in, but even models right now are saying different things. They usually start to agree a bit more as you get closer to the event itself. So according to the GFS, that has it actually moving off of the coast of Southern California instead of moving directly over Southern California. So pretty big differences between the GFS and the ECMWF. And that is going to have big differences in how much rainfall you get and how much wind you get, because on a hurricane, your strongest winds are going to be on this northeastern side right there because the storm is moving forward in that direction. So you also have some velocity from that. But then you also have the counterclockwise circulation around that low, leading to some of the wind impacts there, which means if we are looking at the GFS instead of the European model, that's going to take the low a little bit off the coast, which means the greatest wind impacts are going to be right over San Diego and some of our more populated areas, which are right on the coast. So, yeah, that's going to have some interesting implications there that we're going to have to see. Let's just continue to click through here to see when the heaviest rainfall looks to be showing up for Southern California. So this is now Sunday 8 a.m., Sunday 11 a.m. Should start to see things pick up as we get into Sunday night. And this is the GFS, so remember this is the one that brings the storm a bit farther up the west right here. And that's where it is Monday 5 a.m., directly off of San Diego and Oceanside, meaning your strongest winds are going to be right over your coastal cities right there, leading to very heavy rainfall. If the GFS ends up coming true, we'll definitely have some significant impacts down in Southern California, and then even stretching up into Central California as we get into later into Monday. So just clicking through here, does look like the Central Coast is picking up some rain, but doesn't really look like we're ever in that band of very heavy rainfall. Most of that is going to be down in Southern California. So now let's change this to the European model to see how it differs on that rain coming in. We'll just click down into here. This is Saturday 2 p.m. is where we're starting. Starts to pick up a bit more Saturday afternoon. Start to see the more heavy rain come in Sunday at 5 p.m. and then very heavy rain about Sunday 8 p.m. And then by Sunday 11 p.m., it's almost directly over San Diego and Oceanside. And then it starts to move more into the eastern parts of California. So you notice this one, European model, doesn't really bring any rainfall to the Central Coast. It keeps the storm a lot more to the east. So yeah, we're already seeing some differences between our two models right there. Now let's actually look at total precipitation, and then we can see how that changes between the two different models. So we'll click here, and just fast forward so you can see that rain fill in. So this is the European model. San Diego, 2.5 inches, Oceanside, 2.5 inches, Indio, 4.5 inches, Riverside, over 3, Los Angeles over 4. And then almost nothing for the Central Coast as the storm moves a bit more to the east of California. So that is the European model. Now let's check out the American model. And clicking through here. So San Diego 1.5, Oceanside 2.5, Los Angeles 3, Riverside 3.8, Indio around 5 inches. So pretty similar rainfall amounts, I would say. It looked like less for LA and San Diego, but then it does spread out a bit over a larger area. You see even Atascadero getting 2 inches over here. Now let's check out the wind gusts, because I'm interested to see how the wind gusts change between the two models. So that's at Monday 5 a.m. It's showing 56 mile per hour wind gusts for San Diego, 53 mile per hour wind gusts for Oceanside, Indio 53 miles per hour, and then it starts to move up Monday 8 a.m. That's where Los Angeles is at 53 miles per hour, Riverside 32 miles per hour, Oceanside 56, San Diego 50. So that would still be a tropical storm. Because you remember when we were over here, maybe it was this one. Tropical storm force is greater than 39 mile per hour sustained winds. So this is wind gusts. So that's actually a different thing. That doesn't guarantee it's going to be a tropical storm, although some indications are showing it will be. Then looks like starts to die down as you get into Monday evening. Now let's take a look at the European wind gusts. So right here is probably where the storm's coming in. So that's going to lead to very gusty winds. You notice it's more in the eastern parts of the state. That was the reason I wanted to show this. San Diego gets up to 35 mile per hour winds Sunday at 11 p.m. But then you start to see a lot more of the 50 mile per hour winds more to the east. So yeah, European has moved into the east. GFS has it moving more over Central California, which would spread more rain and wind impacts to more of California, whereas the European model looking like it's more impacts for the eastern parts of the state, although still definitely some impacts throughout Southern California. Now I want to check out cyclonic weather. I saw a video of this website earlier, and this is exactly what I want to look at here. So this is Coral Reef Watch sea surface temperatures. And you notice that separation right there between where you see the red and where you see the green. That's where you have the warm water and the green water. And then this is your temperature anomaly. Notice how much warmer the water is around the equator and around California. That's because we're in an El Nino year. So a lot of the warm water has moved back over to the eastern Pacific. And that's a big part of the reason that we're seeing such a large amount of activity off of Mexico in terms of tropical storms and hurricanes. It's because during an El Nino year, where you have this warm water, you could think of that as the fuel for your hurricanes. So more fuel, more hurricanes. And there's also less wind shear. Whereas actually the opposite happens in the Atlantic. You have more wind shear, so you usually actually get less hurricanes when it's an El Nino year. Eastern Pacific, more hurricanes. Now, I'd love to see if they have that same map right there, but a zoomed in version. Actually, that's a pretty good shot right there as well. But model data, current storms. Yeah, what I'm looking for is to see if we can find these maps, but just for the Eastern Pacific. There's Southeast Pacific. Nope, that's too close. ENSO regions. That's pretty close. Tropical Atlantic, Central Pacific, no. East Pacific. There we go. That's the picture I'm looking for. East Pacific. Just took me a second to find it. So what we're looking at right here, on the left is your sea surface temperatures. That's in Celsius, so I'm not going to be able to translate that, but 80 degrees. Let's see what 80 degrees Celsius is. 80 degrees Celsius to Fahrenheit, because above 80 degrees, we need to go Fahrenheit to Celsius. So 26.6 degrees Celsius. That's the kind of magic number when it comes to hurricanes. Greater than 26 degrees Celsius means greater than 80 degrees Fahrenheit, and that's where your storm is going to get stronger. Less than 26 degrees, so showing up as that little yellow square right there, that's where your hurricane is going to start weakening. So it's that yellow line right there is almost the perfect divider of where the storm is going to get stronger and then where the storm is going to get weaker. So right there, you can see why California doesn't get hurricanes. Throughout this entire path, the storm is going to be getting weaker and weaker. Now, this is a question I had. Has a hurricane ever hit California? So before that, the San Diego hurricane made landfall in October 1858. California's only hurricane landfall on record, research shows. 1997's Nora was the last and only other tropical storm to maintain its status after crossing into California. Interesting. So we had a hurricane in October of 1858 hit California, and that's long enough ago that I'm going to question that, because but more than 100 years old, you can kind of question some of the weather instruments they're using or their data collection techniques. That's like, we often question the warmest temperature of all time is 134 degrees in Death Valley in 1913, but people say, that's more than 100 years ago. I'm not totally sure if that's true. And then it shows 1997, Nora was a tropical storm as it moved into California. There's a whole Wikipedia page about list of California hurricanes. So usually only the remnants of tropical cyclones affect California. That's actually something we're seeing right now. It's the remnants of some of the tropical storms that we've had from off of Mexico pushed some moisture into the atmosphere. That moisture found its way into northern California. That's led to some thunderstorm, lightning activity up there, and the fires that have been starting. So, since 1900, only 2 still tropical storms have hit California, one by direct landfall from offshore, another after making landfall in Mexico. No tropical cyclone has ever made landfall in California at hurricane intensity in recorded history. Okay, so that's saying something different than that other source we were looking at. That one shows remnants of Hurricane Nora over the southwestern U.S. Since 1850, only 8 tropical cyclones have brought gale force winds to the southwestern United States. They are 1858 San Diego hurricane, that was reconstructed as just missing landfall in 1858. So that's the one that is questionably a hurricane or not. And then I'm not going to read this whole list, but then we got Hurricane Nora in 1997. Was downgraded to a tropical storm. And then Kay's remnants passed over Southern California, which brought flooding and 100-mile-per-hour wind gusts to some areas in the region. So that's something you always have to be wary of. When you're making classifications of a tropical storm or a hurricane, you're looking at sustained winds, whereas your wind gusts are going to be much stronger. In most cases, rainfall is the only effect that these cyclones have on California. Sometimes the rainfall is severe enough to cause flooding and damage. For example, floods from Hurricane Kathleen devastated Ocotillo, California, and killed several people. So, explanation for the rarity is most likely going to go along with this picture right here. We have cool water because the current, let's see if I can use my new tool that I have here. There is a cool current that comes down from Alaska. And that brings cold water down the coast because we often have a high pressure system over the Pacific. So you have clockwise rotation around that. And then that brings your cold, I really should be using a blue pen for this. I'll just label that as cold. That's going to bring cold water down from Alaska. And then on top of that, due to the Ekman spiral, which is due to the Coriolis force, not going to get into the science on that, you also get your surface water being pushed away from the coast right there, which leads to upwelling and bringing even more cold water down from below. So you have kind of this triple whammy that brings cold water to the California coast. One, it's coming down from Alaska, so of course it's going to be cold. Then you have your surface waters being pushed away from the coast, and then you have cold water filling up where that surface water was, and your water down below is going to be a lot colder, so that leads to more cold water. So once you have a hurricane cross into that boundary where it's cold, that's going to pretty much make the hurricane lose its intensity, turn into a tropical storm, and then basically just turn into some remnants. Now here is a very different picture. You might have been wondering what this was, and you might be wondering, well, over here, California looks like it's in the red. So is that going to lead to a hurricane in California? But this map is looking at temperature anomaly. So how different is your surface water temperature than what it is normally? And that's because of El Nino. So let's see if I can find... I showed this image in yesterday's live stream. So impacts of El Nino and La Nina on the hurricane season. You have the warm conditions here. What that does is leads to more warmer air. Warm air rises up, leads to more cloud development, more rainfall or thunderstorms or hurricane development. Fewer hurricanes over on the eastern U.S. more hurricanes on the western U.S. due to less vertical wind shear. And then La Nina is going to be the exact opposite of what happens. And let's see. Yeah, not really seeing anything else right there that I need to show. Let's go back to this explanation for rarity, because this will hopefully calm some of the fear that's out there for Hurricane Hilary. I think a lot of people right now, it seems like they think a hurricane is going to hit California, but that's, or at least the level of kind of scary words that they're using would make it seem that way. But again, I don't want to downplay it, because of the rainfall totals that we looked at, we're most likely going to see some flash flooding down in Southern California, and then maybe even pushing into Central California, and then we also are seeing some 50-mile-per-hour wind gusts as well, maybe even more than that. But it's not going to be a hurricane, and here's why. There are two basic reasons why tropical cyclones rarely strike California at tropical storm intensity or higher. Cold sea surface temperatures. What's this picture? No, don't need to see that picture. And the usual upper level steering winds in the eastern Pacific, with sea surface temperatures being more important. Tropical cyclones usually require very warm ocean water to depth, generally above 26.5 degrees. We kind of figured that number out ourselves. So 80 degrees Fahrenheit, extending to a depth of 160 feet. However, the waters off California are cold even in summer. They rarely rise above 75 degrees Fahrenheit in near-shore Southern California, and usually remain below 63 degrees Fahrenheit. I'm going to close that just so the fan calms down on my computer. And usually remain below 63 along most of the rest of the coast and outer coastal waters. Although El Nino events, see what's going on right there, may warm the waters somewhat. This is due primarily to the extensive upwelling of colder subsurface waters caused by the prevailing northwesterly winds acting through the Ekman effect. The winds drive surface water to the right of the wind flow. This is exactly what I was drawing earlier. That is offshore. I'm just mostly reading this to see if I can figure out any new information that I'd be able to talk about in future videos. That is offshore, which draws water up from below to replace it. So cold water comes up to replace the surface water that moved away from the coast. The cold water at the depths is going to reduce the intensity of a hurricane even more. The upwelling further cools the already cool California current, which runs north to south along coastal California and even much of coastal Baja California. That's why we have cold water here, comes down from Alaska. This is the same mechanism which produces coastal California's characteristic fog. So the reason for that, you have all this cool water right there, and then you have some warmer air moving over that cool water, warm, moist air, and then as it cools down, that cooler air can't hold as much of the water vapor in it, so it squeezes it out almost like a sponge into the fog that then moves on the California coast. By contrast, nearshore ocean temperatures along the east coast from New York south to Virginia are normally near 80 degrees Fahrenheit and often near 85 degrees Fahrenheit. It's a big advantage for surfers on the east coast, although I'd say our waves are better. From South Carolina to Florida in the summer and fall. This is also the reason there are so many more tropical fish found on the east coast than on the west coast. Second reason is the general path of tropical cyclones in the eastern Pacific. They generally move north-northwestward or westward due to steering by the prevailing upper-level winds, which take them far out to sea and away from land. So, to understand that, let's go back to this picture right here. Let's go back. I want to go back all the way to the start. So, normally, let's get our drawing tool out here. There's a high over the Pacific, and that has clockwise flow like that So what we were just reading right there is it's these winds that it's talking about. You call these your trade winds. Going cursive. And that, what it's saying is that steers a lot of the storms to the west and away from California. And that's what's so, you could say, abnormal about Hilary, is Hilary is expected to move directly up Baja California. You can see the path of it right there. Let's check out that path again, where it goes from major hurricane all the way until Sunday at 12 a.m. Then it starts to hit that cooler water, and then it turns into a hurricane, so category 1 or 2. And then by the time it gets into Southern California, the big question mark will be if it's still a tropical storm. But it's very rare for that to happen. So, we read that. This is also the reason there are so many more tropical fish found on the East Coast. The second reason is the general path of tropical cyclones, what we were just looking at, mostly moving to the west. These factors make eastern Pacific landfalls improbable north of about central Baja California. Interesting that that matches up so well with this map right here. Even in an El Nino year, much of northern Baja California is going to be below that 80-degree threshold that hurricanes need in order to continue strengthening. And the opposite of that is weakening. In those instances, when upper-level steering winds do allow a more northerly path, much cooler sea surface temperatures quickly weaken tropical cyclones that approach California, although torrential rainfall can still occur. For example, the September 24-hour rainfall record for Los Angeles is held by the 1939 Long Beach tropical storm as of January 2007. 24-hour rainfall record for Los Angeles. And El Cordonazo was a tropical cyclone that affected Southern California September 1939. Formerly a hurricane, it was the only tropical storm to make landfall in California in... So this is your list of tropical cyclones. A lot of these on this list are just remnants that move in, not the tropical storm itself. Sounds like the last actual tropical storm to move in was 1997. I believe that's what it's been saying. That's way too much reading right there. All right, so I think we have found a lot of good information. The last place I'm going to check before I end this live stream is going to be Twitter. Let's just check out what other people are saying about Hurricane Hilary. So Eric Holthouse, I like his last name, will bring 2 to 3 years of rain in 3 days to the deserts. Catastrophic flooding is possible. Get ready, California. What about this one? Hurricane Hilary will drag enormous amounts of tropical moisture into California and the desert southwest. So there you see it, and then it starts to move up into California. Oh, Dr. Levi Cowan. Actually, let's check out his website. Tropical Tidbits. And let's see if he has any. There's the picture of Hurricane Hilary. Current storms. Oh, this is exactly what I was looking for. Perfect. Okay, so global and hurricane. So what these lines are is all the different models. And right here, you can see some of the big differences. I can't really tell which model is which. It's a bit cluttered. But you can see that there is some variation in what these models think is going to happen. Some of them have the storm going a bit more to the west. And then some have the storm going a bit more to the east. Now, which one is actually true is a little bit harder to say. Let's check out this one. This is going to be your GFS ensembles. Yeah, it looks like that middle one has it going almost directly over San Diego. So that's where you're going to have some very heavy rainfall, very gusty winds. And you can see how the color changes as it gets closer to California. It goes from that like dark red color where it's a major hurricane to the more yellow color where it will be a tropical storm or tropical depression or even post-tropical cyclone. And then finally, this is the other one that I wanted to see. So glad that Levi Cowan, I think I'm saying his last name right, Cowan, posted on Twitter because I meant to look at his website. So this is forecast hour on the bottom, wind speed in knots on the y-axis. So this is showing 36 hours from now, the storm looks to be at its peak. And some of these models actually have it going category 5. I've heard more reports that it's expected to reach category 4. And then you can see how as you get later in time, so 2 days out, 3 days out, that's where it starts moving closer to California, where it's going to be moving into that colder water. And then you can see how quickly the storm decreases in intensity. And some of these seem to decrease a lot faster than others. Those are most likely going to be the ones that have the storm moving over land. So that is very interesting as well. And then what did he say? He's one of the best. If you don't follow Tropical Tidbits on Twitter or YouTube, or X or YouTube, I would definitely suggest it. So expected move into Southern California Sunday night and Monday. The good news is that cold water off California will take most of the wind-related punch out of Hilary. She will not be a hurricane in California. I agree completely. However, several inches of rain over a wide region of southwestern U.S. will elevate risk for flash flooding. Some of this rain will be beneficial for drought-stricken areas, but some areas could receive too much water too fast. On top of that, it's also, it's maybe not the way that you'd want to pick up your rainfall, but so too much over too short of a period of time. But any rainfall in California in the middle of August is great news for wildfire. So that's one aspect. And then photos he posted, greatest flash flood risk over the next 5 days. Notice it's kind of on that northeastern side of where a lot of those tracks have it moving in. There you see it go from a major hurricane to a hurricane. Oh, this is one map that actually has it as a tropical storm. 6 a.m. Monday. That's interesting. That's one thing that we hadn't seen yet. And then this is going to be your sea surface temperatures. You can see where it goes from 26 degrees and it's still in the yellow. That's where the storm is still going to be strengthening, to 25 degrees Celsius where the storm is going to be weakening. Very interesting. Okay. Just some ads there. Tracking Hurricane Hilary. The storm is now expected to strengthen into a Category 4 hurricane before hitting California as a tropical storm. Alright, so that's 2 reports now that are saying it will be a tropical storm when it hits California. Tropical storm warnings and watches are now in effect for southern parts of Baja California Sur. Okay, that shows some of the rainfall expected Saturday through Monday. Is calling for 5 to 10 inches of rain across the inland deserts and mountains of SoCal, which would bring severe flash flooding. Palm Springs is forecast to receive more than a year's worth of rain in less than 72 hours. So just clicking on that image to make it a little bit larger. See, this, whatever model National Weather Service is using, has about 1.5 inches to 2 inches for much of San Diego. And then as you get more into the central parts of more central parts of Southern California, that's where you have some of the potential for 5 to maybe even 10 inches of rain. And there's another shot of Hurricane Hilary strengthening. You're starting to see a bit more of the eye showing up. And yeah, a lot of people are starting to say a lot of the same things. I think we've covered all of the information that we can possibly find as of right now. We are definitely going to be keeping a close eye on Hurricane Hilary as we move forward. I'll continue to do these updates over the next few days. And then if you're interested in some of the wildfire activity that's been happening, I posted a video of that earlier today to both YouTube and Twitter, and you can find that there if you're interested in wildfire in California. If you're interested in Hurricane Hilary, stay tuned. This is definitely going to be a storm that we follow closely over the next couple of days because there's still a lot of question marks out there, and we are definitely going to see some changes before this storm actually makes landfall. So thanks for watching, and hope that this video was helpful.